In the previous video, we had studied about how a scientific notation is given and how can we add, multiply, subtract and divide scientific notation. In this video, we are going to be studying about significant figures. So there are two reasons why, as mentioned before, there is uncertainty in measurement. One is because of the observer or the person who's following or doing certain calculations or measuring something. And the second is because of the device which is being used. For example, let's assume a mass of a particular object is measured to be 5.456. Is this value right? I don't think so, because here we've not written units. So let's assume that the person had to measure 5.456 grams. And the analytical balance has an accuracy of plus or minus 0.001, which means that the substance which was measured, the mass or weight of the mass of the substance could be 5.455 or it could be 5.457. So we know all the values except this one with certainty. So the significant figures are the meaningful digits which are known with certainty plus one which is not certain. So there are certain rules which determine as to how many significant figures are present. So pay attention because we will be doing it with examples as always. Okay, so the first one is all the non-zero digits are significant. So all non-zero digits are significant. Makes sense, right? I mean, if any value is not equal to 0, then obviously that digit is significant. This is what we've learned even, when we were learning numbers before. So 04 is not, the 0 won't be significant. So let's assume 4.5, 2.87, 4.525. Now in these three numbers, this has two non-zero digits, which means it has two significant figures. This one on the other hand has three non-zero digits, which means it has three significant figures. Whereas in the third case, it has four non-zero digits, which means it has four significant figures. So all the non-zero digits are going to be significant. That's the first rule. The second rule is zeros preceding the first non-zero digit are not significant. Okay, this I think is better understood with an example and then we'll go to the rule. Okay, let's take the example of 0.004. Okay, so the rule states that the zeros preceding non-zero not significant. Okay, so here preceding means before. Okay, so before this 4 is a non-zero digit, right? So these three zeros are not significant, making the number of significant figures in this number only as 1. Okay, another example, 0.053. Think about it. Here you have two digits which are not zero. The two zeros before these digits are not going to be significant, so the number of significant figures are 2. And in the third case, 0.214 is having 1, 2 and 3 significant figures. So the first rule is about the non-zero digits. All of them are significant. The second rule is that the preceding, the the zeros which are before the first non-zero digit, the first one, okay, are not significant. The third rule is actually pretty simple. Okay, and again, so we'll do 2.004. Now this one has 4 significant figures. This is because the zeros which are present in between the non-zero digits are considered significant. Okay, so in between, so these two zeros are in between 2 and 4. Because of that, these two are also considered significant, thereby making the total number of significant figures in this number as 4. Okay, so zeros, now another example, 3.01. Again, this 0 is also going to be significant, thereby making the total number of significant figures as 3. And 6.023 has a 0 in between, but because it's surrounded by 2 non-zero digits, it has 4 significant figures. Okay, so the zeros which are before the first non-zero digit, they're not significant, but if they are in between the non-zero digits, they are significant. Now let's look at the last point. The last point is that zeros at the end or at the right of the number are significant only if they are on the right side of the decimal point. The zeros or after the decimal point show how accurate a particular machine is. Now, let's take an example again, 0.300. In this number, this 0 is before, so it follows the second one. So it does not count, it will not be considered a significant figure, but the zeros which are after, which are on the right, they are considered significant. So this number has 3 significant figures. Similarly, let's assume you have 244.0. Okay, so this number has 1, 2, 3 and 4 significant figures because zeros at the end or the right are significant only if they are on the right side of the decimal point. So 244.0 has 1, 2, 3 and 4 significant figures. 244.00 has 5 significant figures because this is on the right side of the decimal point, and 244.000 would have 6 significant figures because these 3 zeros are on the right side of the decimal point. So if we count something and we will write them as, let's first recap on all of that, and I'd like to add an extra point to all of this. So all the non-zero digits are considered significant, which means if anything so any non-zero digit is significant. You can write that down as it is. It's only when zeros are involved that there is a slight change in the roots. So if 0 is before the first non-zero digit, it's the first non-zero digit, then they are not significant. So these zeros are not going to be significant. If they are in between 2 digits which are non-zero or 2 non-zero digits, then the 0 is considered significant. And if the 0 is on the right side, okay, and if it is after the decimal point, not before. Now if I had 10, the total number would only be 4 because this 0 is not considered. Okay, so only if it is on the right side of the decimal point. Also, it is very important that these zeros actually denote one very important factor when it comes to the machine, is that it's that accurate. Okay, if it's 244.000, this is obviously going to be more accurate than 244.0, because after this the value could have been 5, 6, 7 or whatever, but we don't know what it is, right? So this is more accurate. So these zeros after the decimal point actually denote as to how accurate a particular substance is, or sorry, a particular machine is. Now we talk when we have 10 pencils, okay, in our hand, and we count it, and we will just write the total number of pencils or pens as 10. Now this value can have any number of significant figures, making it have an infinite number of significant figure. Okay, so if I write 10.0000, it stays the same. If I write 10.0, it's the same, because no matter what, the total number of pens or pencils is going to stay 10. So such values will have an infinite number of significant figures. Now here there's also one very important thing, that we use scientific notation for denoting the number of significant figures. Okay, so you remember, right, n into 10 to the power n, where n is an exponent and this n is the numerical value. This n can be plus, can have a positive or a negative value. So let's take examples. 0.0000054. As per our general rules of denoting or for scientific notation, we should have at least one non-zero digit before our decimal point. For the ones who have not checked out, do check out the video that I did on that we studied about scientific notation, how to add, subtract, divide and multiply scientific notation. So here you will be shifting the decimal point here, right? So this value, because we are shifting it to the right side, right? Because we are shifting it to the right side, it has a negative value, okay? And it is going to be 5.4 into 10 to the power minus 5. And these two are non-zero digits. Because of that, it will have two significant figures. On the other hand, our Avogadro number 6.023 into 10 to the power 23 will have 1, 2, 3 and 4. 4 significant figures. Okay, so if 5,000, let's take an example. Okay, so I have 5,000 as a number and we need to write it in terms of only 3 significant figures. Instead of this has one significant figure, right? So we'll be writing it as 5.00. Decimal, after the decimal, the zeros are counted and they are significant. So 5.00 into 10 to the power 3. So this has 3 significant figures. Okay, so to sum up, all the we learned about significant figures. Significant figures are the meaningful digits which are known with certainty, plus one which is considered to be uncertain, and uncertainty is because of the person who is measuring or because of the device which is being used. The first rule is all the non-zero digits are significant. The second one is zeros which precede the non-zero digits are the first non-zero digit are not significant. The reason I keep stressing on the first non-zero digit is because over here, if you see, you have 2.004, okay, and here this is a non-zero digit and preceding it are 2 zeros, but because they are in between 2 non-zero digits, they are considered significant. But had there not been a 2 here, which is the case over here, you have this 4 as your first non-zero digit, which is considered significant. So the zeros which are before the first non-zero digit, they are not significant. The zeros which are between non-zero digits are significant, and the zeros at the right side after the decimal point are considered significant. With this, we complete the topic significant figures. Does not mean it's not done. We have to learn about the addition and subtraction of subtraction, multiplication and division of significant figures. That will be the topic of the next video. Do check it out.